Okay, hello everyone. Okay, in this video is for the mechanics of materials and we have finished to introduce the force vector calculation and position vector calculation, and right now we are going to we combine these two together, force and position, and then we are going to introduce maybe a little, it's still a kind of review. It's called moment calculation. And the moment, like I said before, moment is just the torque. Okay, moment is just the torque. Okay, but I don't know why in mechanics material they just call it moment. Okay, but actually in general physics, if you have a first year physics course, they call it torque. Okay, it's in Chinese called 力矩. Okay, 力矩. Okay, torque. Okay, so let me see. Okay, this is 力矩. Okay, let's write Chinese here. Okay, it's torque or moment. And it's the tendency of the force to cause a body to rotate about a point, the point or axis. Okay, so the moment will cause the body rotate about or around an axis. Okay, and how to calculate the moment? Okay, first of all, let's start with the planar case. Okay, in planar case, the calculation of moment, yeah, I think you all learn this in your general physics or high school physics. A moment equal to your force times your, it's lever arm. I would call it lever arm. Okay, lever arm in Chinese called 力臂. Okay, lever arm. And especially when we trying to calculate a moment, we will have a reference point. Okay, MO. Okay, reference point, or actually it's a reference axis. Okay, actually there is axis. Okay, not only a point, it's an axis. Okay, and the reference point is very important in moment calculation, because if you have different reference point, you will have different moment. Okay, so before you calculate the moment, you really need to know where is your reference point. That's very important. Where is the reference point? You have different reference point, you will have different moment. Okay, and so force. The F is the force and the magnitude of force. And next thing is what is lever arm? Lever arm. Okay, be careful what is lever arm is. Lever arm is the perpendicular distance from O to its line of action of forces of force. So for example, I draw an example here. Okay, so suppose I have a color. Okay, suppose I have reference point O, and maybe I have a device here, a stick on reference in the reference point O. I have a stick and apply a force here. The force is a vector, right? I apply a force here. So what is the lever arm? I mean, suppose this is the distance of the object is d. Okay, the distance of the object is d. Okay, here is d. Okay, so the moment with respect to the point O is equal to F times d. Okay, I think you all learned this before. Of course, that's not equal to F times d. Okay, we need to find the lever arm. Okay, the lever arm is the perpendicular distance from O to its line of action of force. Okay, line of action of force, that means we can extend the force vector along its direction. Okay, let's see. Okay, I can make extension here. The extension this is called, the green dashed line is called line of action of force. Action of force. Simply speaking, it's just the what's called it, the vector of force. No, I think it just makes extension of your force vector. Yeah, like what I would say, just make an extension of your force vector, and it's a straight line. Okay, it's straight. Okay, not curved. It's straight extension of your force vector. And you say that d is the perpendicular distance. Okay, so perpendicular distance to the line of the action, to its line of action of force. So it's here. Okay, and here it's perpendicular. Okay, this pink one, or this is the perpendicular distance between the origin, the reference point O, and to the line of the action of the force. So this is just your lever arm. This is your lever arm. Okay, so your moment. Okay, this force caused the moment of this force. The moment caused by this force is F times the lever arm. F times the lever arm, and lever arm is here. Okay, so just be careful. The lever arm is a perpendicular distance from O to its line of action of force. So this is very important concept, and this will use a lot in the later calculations. Okay, and actually, and also moment is a vector. Okay, and from this formula, maybe you will say, well, it doesn't look like this is a vector, but actually there's a vector. Okay, FD. Okay, we will talk about this later. Okay, we'll talk about it later because the F times D. Okay, the moment is a vector, and vector is point out. The direction of moment is point out to the screen. Okay, especially I think it's D cross R cross F. Let me see. Okay, I think it's point. This in this case is point into the screen. Okay, okay, the direction of moment. Okay, the direction of moment. Okay, point into the screen because we will talk about is the formal calculation of moment is R cross F, and here so it's R cross F, right hand rule R cross F, D cross F. So if D cross F, your thumb is point into the screen. So actually, this moment, okay, this force causes a moment with respect to this point O, and the direction is into the screen, and it's follow the right hand rule because D cross F, and point into the screen. And for example, this is D is point here. Yeah, from the reference point O. So D and the point to this direction. D is here and F is here, and D is here, F is here, and then D cross F. D. If you if you look at the screen, it's D cross F, D cross F, D cross F, D cross F. Okay, and your thumb is point up like this one. Your thumb is point up. Okay, and D cross F, and you have moment. F times D is a magnitude of moment, and its direction is point up, point up. Okay, so even if in 2D system you still got the vector of the moment. Okay, and this just give you a magnitude. Okay, but the direction of the moment is you need to use the right hand rule to judge where is the direction of this moment. Okay, is the direction of the moment. Okay, okay, it's D equals F. Okay, we'll talk about this later. D equals F. Okay, it's point up from this screen to point up. And for this, okay, D is here. Okay, this is reference point. Oh, D is here. Okay, F is here. So D equals F. D cross F. Okay, D here cross F. So it's point. It's point out to the screen. Point out to the screen. Okay. Okay, the direction of this moment in this case is point out to the screen. Okay, D cross F, your thumb direction is point out to the screen. Okay, and because moment is a vector, okay, so when you sum of all the moment vector is equal to it's called resultant moment. Okay, just like we did on resultant force, you sum of all your force vector is called resultant force, and the sum of your own moment vector is called resultant moment. Okay, so I don't need to explain this that much. Okay, and the next few slides, yeah, I won't do the calculation of the moment. I just want to know where is the lever arm. I just want to practice where is the lever arm. Okay, because it is a very simple calculation of the moment. I think you all know how to calculate it. So in this very simple problem, I just want to find where is the lever arm. Where is the lever arm? Okay, and then we'll use the example to 3.2 to tell you introduce you about the sign convention. Okay, so let's start from example 3.1. Okay, like I said, I won't calculate the moment of this problem. I just want to know, okay, where is the lever arm? Where is the lever arm? Okay, for problem lever arm. Okay, this is the force. The force is here. The force is here. Oh, sorry. Okay, the force is here. Okay, and O is here. So the lever arm is the perpendicular distance between the reference point O to perpendicular distance between the point O and to the line of line of action of force. So it's perpendicular. Okay, so the lever arm in this problem is 2m. Okay. And so at that point, I try to be okay. The force vector is here. Okay, the O is here. So the line of action is here because point to here. The force is point to the left. So we just draw a line of action, the extension of the force vector, and what's the perpendicular distance between a line of action and point O. Okay, I think it's here. Okay, so here is your lever arm. It's 0.75. Okay, and now here, there's a force vector here, 4 kilonewton, and point down. It's point down. Okay, so let's draw the line of the force, line of action of force. Okay, that's the line of action of force. And the reference point O is here. So what's the perpendicular distance between the O and line and to the line of action of force? So it's here, or HD here. So I told you this is 2 and this is 1. Okay, so how to get the distance here? Okay, yeah, he give you here's a 30 degree. Okay, 30, I think 30 degree. Okay, so here is 1. So the question mark is 1 times cosine is 30 degree. So the lever arm is 2 plus 1 times cosine is 30 degree. And this is calculate yourself. I think cosine 30 degree. Okay, so cosine 30 degree, what's the value of 1 times cosine 30 degree? Okay. Okay, 0.866 and plus 2 is 2, so it's 2.866. Okay, it's m. Okay. And so, so that's very two first simple example. I just want to practice to find a lever arm. Okay, next slide. Okay, for this slide, okay, it's just like a little more complicated. Okay, so here is like a cantilever, but it's a bent cantilever. This here is bent cantilever. Okay, so we apply a force here. Okay, it's 600 Newton. Okay, so a reference point O is here. Okay, where is the lever arm? So first of all, we draw a line of action, just extension your force vector, and what's the distance between the line of action and the line of action of force and your point O. Okay, it's here. Okay, so this is the lever arm. This is a lever arm. So how to calculate this lever arm? It doesn't give you the lever arm here directly. He give you the distance here is 0.5 and give you the degree here. So your lever arm is 0.5 times sine 45 degree. Okay, so I think it's okay, 0.5 times sine 45 degree. Okay, it's 0.0353. Okay, the final one is, okay, this is line of action or force here, 7 kilonewton, and the reference point O is here. So your lever arm is this distance. Okay, it's not 4. Okay, it's not 4. Okay, so what's the distance here? It's 4. I tell you this is 1, so your lever arm is 3. Okay. Okay, a simple practice to let you familiar with how to find the lever arm. Okay. Okay, so I will use this example as to finish this section. Okay, just find example 3.2, find the resultant moment. Okay, and here is this is okay on left side also a bend cantilever. Yeah, Okay, and there is all one, two, three, four. There is four forces acting on this member. Okay, acting on this member, and it say determine the resultant moment about this four force acting on the rod. Show in figure 3.5 about the point O. Okay, and use this example, I will also show you the sign convention. In moment calculation, okay, we have a convention here. If it's clockwise, it's negative, and it's counter. And if it's counterclockwise, it's called positive. So this is clockwise, and this is count counterclockwise. Okay, clockwise, negative, counterclockwise is positive. That's a convention. Okay, without this convention, you cannot ask why. Okay, that's a convention we used to it. Okay, so don't change this rule. Okay, and okay, so let's start with the force with here. It's 15 Newton. Okay, 15 Newton. Okay, reference point always here. So the line of action is here, and the perpendicular distance between the force and the reference point O is here. Perpendicular distance here, so it's 2. So here the first is 50 times 2 is equal to 100. Okay, and the next thing is clockwise or counterclockwise. Okay, because this reference point is here, so O, and the force is pulling here, so it looks like will be, yeah, look at the screen, it pulls down here, so it will be rotate like this. You point down here, you apply the force here, he will rotate like this, so it's clockwise. So it's clockwise. Okay. And the second one, the force is 60 Newton. Okay, it's a line of action is here. Point O is here. You will find the perpendicular distance between the O and line of action is 0. Okay, it's 0. Okay, think about this yourself. Okay, and next thing is 20 Newton force. 20 Newton force is here. Okay, and then I just okay, erase this. Okay. Okay, here. Okay, 20 force, 20 Newton, 20 Newton of force. Okay, its line of action is here. Make an extension of force vector, and the reference point O is here. So this lever arm is here. Okay, so what's the distance here? Okay, it doesn't give you distance here directly, but he give you here is 3. This is 3 meters. 3 meters, and it's 3 angle here is 30 degrees, so 3 times sine 30 degree. 3 times sine 30 degree. Okay, 3 times sine 30 degree. Yeah, trigonometry. Okay, don't forget your trigonometry. Okay, 三角函数, don't forget it. Okay, sine times sine 30 degree. Okay, so it's 1.5, and times 20. It's, I think it's 30 something. Okay. Okay. And next, the final one is the force here, 40 Newton downward. We forgot to determine this clockwise, counterclockwise, because the force factor is here, and the reference point O is here. So this force will cause a rotation around this point O. So its rotation will be like this. Look at this screen. You pull the force here will cause a rotation like this. Okay, the force is going to this direction. You point the force, and the rotation will be like this. So it's counterclockwise. Okay, the final one, the 40 force Newton, 40 Newton force, point downward, line of action is here. Okay, the distance from the perpendicular distance between the reference point and the line of action of force is, the lever arm is here. So its distance 2 plus 2 plus 3 times cosine 30 degree. Okay. Okay, 3 times cosine 30 degrees. So let's see what's the result. 2 plus 2 plus 3 times cosine 30 degree. Okay, and times 40. So let's say it's 263.9. Okay, so okay, and the force is here, so it will cause the rotation clockwise. hmm Yeah, be careful to deter. Yeah, be careful when you determine the direction. Just think about it, not jump into conclusion very quickly. Just think about it. Just think about it. Calm down. Think about it and make your final decision. So I think it's clockwise. Okay, so the convention here we say the clockwise negative, counterclockwise positive. So let's sum all this moment together. So minus 100 and plus 30 and minus 263.9. So it will be minus 333.9, I think. Yeah, yeah, the answer is 334. I think this is just run, yeah, run your answer to zero decimal point. Okay, and don't forget the unit of the moment. In most cases, with the unit of moment is Newton times meter, because in MKS system we like everything represented by Newton, meter, kilogram, and second. Okay, and moment it's most of time is Newton times the meter. Okay, and so okay, so this is just the 2D, not 2D, planar system, the moment calculation on the planar system. Okay, just force times your lever arm, and be careful to find your lever, where your lever arm is and what's the value of your lever arm. Okay, but this is a planar case. Okay, but in the more realistic problem, we are dealing with 3D plus 3D world. Okay, so if it's in 3D system, you use the F force magnitude times the lever arm, and that doesn't work in 3D system. So we will talk about you need to use some other tools to help you to calculate the moment in 3D space. And we'll talk about the tool in the next video, and I'll just stop the video here. Okay, see you in next time. Bye bye. Okay.